Hello students, welcome to Educate. Today we are going to start with chapter number 7 of class 12 physics, that is alternating current. So you are familiar with alternating current and direct current. If you remember, the graph of alternating current is like this, that is sine wave. We use y equal to a sine omega t, where a is amplitude. So if we write current, then we write it like this: I equal to I0 sine omega t, where I0 is the peak value and I is instantaneous current. Instantaneous current means at any instant. And if we write voltage also, so we write V equal to V0 sine omega t. Here V0 will be peak voltage. So if this graph represents current, so voltage will be similar, but its value will be little higher, right? So this is I, this is V, but both are alternating because they are changing their direction. And after this period, this is time period t, after this it is being repeated, right? So now we are going to study it in detail. Here AC voltage applied to a resistor. When AC voltage, symbol of AC will be like this. We will draw this symbol inside the box and we will assume that this is AC source. So here in this circuit, this is AC source and this is resistance. So what happens? Voltage will be V equal to V0 or Vm, both means same thing, maximum value sine omega t. And here if we divide it by resistance, so V upon I will be Vm upon, sorry, if we divide by resistance, so we get V upon R equal to Vm upon R sine omega t. We can write it as I equal to Im sine omega t. So we can say from here omega t sine omega t. So both voltage and current are in same phase. The same thing is represented here by the phase diagram, in which the two are in same phase. And here this is voltage and this is current. Maximum value, this peak value of voltage, this peak value of current, right? So here if we want to find out maximum current or maximum voltage, then sine omega t we can make 1, so we will get that value, right? Now we are going to see power consumed in AC circuit containing a resistance. So power consumed can be easily found by using formula of average. So if you remember, P equal to VI, and if we want to find out average power, so we can write this VI average, right? And if you remember, V is Vm sine omega t into Im sine omega t, right? This symbol means average value. So here Vm and Im can be separated, and then sine square omega t. Now average value of sine square omega t is 1 by 2. So average power consumed will be Vm into Im divided by 2, or we can write it Vm divided by root 2 into Im divided by root 2. And Vm upon root 2 is called VRMS, root mean square voltage, and this is IRMS. So power consumed in AC circuit containing resistance only is given by VRMS into IRMS. Right? So this thing is clear. This value half can be found by using integration method also, but I am not going to do that. So you have to memorize this at this time. Later on, when you have studied the topic definite integral, after that you can use it, you can derive. So here the average value of here they are saying that if you find the average value of suppose you take 0 to 2 pi and you just write average value of sine omega t dt. So what do you get? You will get 0, right? So whenever we want to define average value, then we just take half cycle. We take effective value or IRMS value. So here 2-3 things you must note, that is I is instantaneous current, IM is maximum current, IRMS is root mean square value, and I average, there is another value also, that is 2 upon pi of I maximum, and IRMS, as I told you, it is I maximum divided by root 2. Similarly, for voltage, V is instantaneous voltage, Vm is maximum voltage, and VRMS root mean square voltage, and V average. So V, you know, Vm, you know, VRMS is Vm divided by root 2, and V average is 2 upon pi and V maximum. So these things you have to memorize. So these concepts will make calculation easier, and you can easily understand the functions. So here the basic thing is given as I told you. So here V equal to a Vm by root 2, Im by root 2. Same thing as I explained to you earlier. Now this is also same thing as I told you. So whenever you will be given equation, like suppose you are given V equal to 200 sine say 100t, in that case this value will be what? So this will be a root mean square value generally we use. Sorry, since this equation represents V equal to V0 sine omega t, so this value will correspond to V0, or this we can write Vm into sine omega t. So this value will be Vm, right? Vm equal to 200 volt. Now suppose we want to find out VRMS. So what we do? We take 200 divided by root 2. And the V average, suppose we want to find out. So just write 2 upon pi and then into 200 volt. So I think you have understood. Correct? So now we are going to solve one numerical. Numerical says a light bulb is rated 100 watt for a 200 volt supply. So from this rating we can find the resistance. What is formula for resistance? So P equal to V into I. We have to find out resistance. So P is given. So here we can write V into V upon R is equal to P. And we have to find out R. So V square upon P. V square means 220 square divided by P is given as 100. So this will give 48400 divided by 100. So it will give 484 ohm. So we have got resistance. Now our concern is to get peak voltage. So peak voltage, as you know, here the voltage that we have got, this is RMS voltage, because the rating of bulb is done on the basis of RMS value. So we can get peak voltage. So V maximum or V0 is equal to V RMS multiplied by root 2. Because if you remember, I told you V0 divided by root 2 gives VRMS, right? So here VRMS is given as 220 into multiplied by root 2. If you evaluate it, it will come out to be 311 volt, right? So we have got peak voltage and then we need current. So current can be easily found if it is operated at the same voltage 220 volt, then there is no problem. P equal to VI. So just write P equal to VI and then VI evaluate I. So P upon V. So P is given 100 and V is 220. So this will come out to be 0.454 ampere. Correct? Now, here the same thing is represented by phasor diagram. We have already seen this diagram that this is voltage, this is current. Now, if we write in terms of the angle, so this axis here, this angle is omega t. So, as you observe, the peak value of current is less than the peak voltage. So, here the same is done here. Up to this height, we assume that this is peak value of current, and up to this height, it is voltage. So, they are in same direction because angle is same, sine omega t in both the cases. So, here this same line represents current and voltage, but strength of current is less than that of voltage. So this is phasor diagram, right? So you have understood here phase difference between the two means current and voltage is 0 degree. Now we are going to see another case. Another case is when inductor is applied across an AC source. In that case, what happens? As you know that there will be an induced EMF which will oppose the flow of current. So we can say that applied voltage plus induced voltage will be 0. So the same thing is written here. Figure shows an AC source connected to an inductor. Usually inductors have appreciable resistance in their winding, but we shall assume that this inductor has negligible resistance. The circuit is purely inductive as AC circuit. Let the voltage across the source be V equal to Vm sine omega t. You know that AC source is written like this. Using the Kirchhoff's loop rule, total voltage must be 0. So we can say V minus sum of the two voltage. This will be E or V equal to Vm sine omega t, and this will be minus L di by dt. Sum of the two must be 0. So we write V minus L di by dt equal to 0, and then we further proceed. Here one important result we are going to derive. So di by dt will be equal to V upon L, or V is Vm sine omega t divided by L, right? And then we can integrate it to get I. So if we integrate di by dt times dt equal to Vm upon L sine omega t dt, so dt will cancel out, and then integration of di will give I, and then this will become sine omega t. Integration gives minus cos omega t divided by omega, so it becomes minus Vm cos omega t divided by omega plus a constant, and we choose constant in such a way that it should become 0. So I equal to minus Vm omega L cos omega t. Here what we have to do, we have to compare it with the original voltage, and then our concern is to get the phase difference between voltage and current. So V equal to V0 or Vm sine omega t, and here I is equal to minus Vm divided by omega L cos omega t, right? So here minus sign is there, that should be absorbed, so it should be written like Vm. Here one more thing we can introduce, that is inductive reactance, which is resistance offered by a coil. This is omega L. So in place of this Vm upon XL, we can write Vm is voltage, XL is resistance, so it will be current, right? So let's write it as I0. So here it will become I0, and this minus sign we are going to absorb by writing it sine, and let's write it omega t minus pi by 2. Why? If you remember, sine pi by 2 minus omega t will give cos omega t, right? But if it is just opposite, then minus sign you have to take common. Same thing you will get. So we have written like this. Now our concern is to make a comparison between voltage and current in terms of phase. So V equal to V0 sine omega t, and I equal to I0 sine omega t minus pi by 2. So what do you observe here? It can be clearly said that current lags voltage by pi by 2. So we can see it through diagram. Diagram is drawn here. Like this. You can easily understand this is voltage. Current is starting from here, which is lagging by pi by 2. So current is going like this. So when we draw phase diagram, so current will lag voltage by pi by 2. So current is here, voltage is here, right? And this angle is omega t. Omega t is the angle that this x-axis makes with voltage, right? So I think you have understood. Now further, next point is to find out power consumed in an AC circuit when there is an inductor. So average power consumed we can find by applying formula average V value V into, let's write it as V into I, average, and we are considering it for inductor. So for inductor, if you remember, it will become V will become Vm sine omega t, and I is either you write with minus sign I m, and then it is cos omega t and average, right? Do one thing here, we can write minus Im into Vm outside, then average of sine omega t times cos omega t, right? And if you remember, 2 sine theta cos theta gives sine 2 theta, right? So here it will become minus Im into Vm divided by 2, and let's write it as 2 sine omega t cos omega t or sine 2 omega t. And if you remember, for complete cycle up to here, average value if we find, so this is positive, this is negative, so here if you find average value, so that will be 0, right? So this term will become 0. So we can say that average power consumed in case of inductor is 0. This can be done by using integration method also, but that is not necessary. Now there is one question based on inductor. So question says, a pure inductor of 25 millihenry, value of L is given as 25 into 10 to the power minus 3 Henry, is connected to a source of 220 volt, V equal to 220 volt, Find the inductive reactance. We have to find out XL, that is omega L or 2 pi FL. So L is given, if frequency is given, then we can easily evaluate 2 into 2, 3.14 into frequency is 50 into L is given as 25 into 10 power minus 3. We can evaluate and that would be 7.85 ohm, right? And then comes, we have to find out current. So V upon XL will be current. So value of V is given 220 divided by XL, we have found 7.85. So this will come out to be 28 ampere. Now, let's see next question. Next question is, when a capacitor is connected with AC source, then what happens? So here, obviously, Q equal to CV means there will be one voltage. So figure source and AC source, E generating voltage V equal to Vm sin omega t connected to capacitor only, a purely capacitive AC circuit. When a capacitor is connected to a voltage source in a DC circuit, current flow for the short time required to charge the capacitor. As you know, as charge accumulates on the capacitor plates, the voltage across them increases, opposing the current. That is, a capacitor in a DC circuit will limit or oppose the current as it changes. When the capacitor is fully charged, the current in the circuit falls to zero. That is steady state case. Now, when capacitor is connected to an AC source, this was the description about capacitor when it is connected to DC source. Now, when it is connected to AC source, then what happens? So, in this figure, the same thing is shown. When the capacitor is connected to an AC source, it limits or regulates the current, but does not completely prevent the flow of charge. The capacitor is alternatively charged and discharged as the current reverses in each cycle. Let Q be the charge on the capacitor at any time. The instantaneous voltage V across the capacitor is from Q equal to CV, V will be Q upon C. So from Kirchhoff's law, obviously same voltage should be there. So applied voltage Vm sin omega t equal to voltage across this. So that is Q upon C. Now we have to find out the current, and if you remember, dq by dt is current. So we have to differentiate it. So for this, what do we do? I equal to dq by dt. So d upon dt of q will be C Vm sin omega t. We put this value, right? And differentiation of sin omega t will give cos omega t times omega. So this omega C Vm cos omega t will be left. So let's write this term because here some important result is hidden. So we have got I equal to omega times C times Vm times cos omega t, right? This can be written as Vm times 1 upon omega C, right? Here omega C term 1 upon omega C. So is it correct? No. Here you have to write it 1 upon omega C, right? And then cos omega t. So this term can be written as capacitive reactance denoted as XC, right? And this is cos omega t. This can be written as voltage divided by resistance will give current. So we write it as I0 or Im, and here we can write it as sin omega t plus pi by 2, because sin omega t plus pi by 2 will give cos omega t, correct? So in this case, what is happening? If you compare it, V equal to V0 sin omega t, you will find that current leads voltage by pi by 2, right? And here one more important term we have seen, that capacitive reactance is given by 1 upon omega C. Here, if you write the values like 2 pi fc and consider the case of DC current whose frequency is 0, then what will happen? Denominator will become 0. It means Xc will be infinite. It means what will happen? It means current will not be allowed anymore because this reactance will become infinite. Correct? So thing is clear. Now here also we will try to find out the average power consumed, and this will also be 0. So let's see how. So average power consumed, so P average equal to V M, not VM, just take VRMS, VI average. We put the values V0 sine omega t times I0 cos omega t, right? So here V0, I0 outside, sine omega t into cos omega t. Then we can write it V0, I0 divided by 2, and we include 2 inside, 2 sine omega t into cos omega t. And this will become V0, I0 divided by 2, and this average of sine 2 omega t. And if you remember, as I told you, average of sine 2 omega t will become 0. So again, you will get 0. It means only in case of resistance power is consumed, in case of capacitance and inductance no power is consumed, right? Let's see some numericals, but there is one theory question also here. A lamp is connected in series with a capacitor. Predict your observations for DC and AC connections. What happens in each case if the capacitance of the capacitor is reduced? So as you have seen, capacitive reactance is given by 1 upon omega c. If omega increases, then what will happen? So, and also here two factors are there. One is omega, another is c. So both we will consider according to question. When a DC source is connected to a capacitor, right? The capacitor gets charged, and after charging no current flows in the circuit and the lamp will not glow. That is obvious. There will be no change even if C is reduced in that case, since current is not flowing. With an AC source, the capacitor offers capacitive reactance this 1 upon omega C, right? If omega remains same and C is decreased, in that case what will happen? If C is decreased, then capacitive reactance will increase. If it increases, then current will reduce, right? The lamp will shine, reducing C will increase reactance and the lamp will shine less brightly. Now let's see what numerical here. This numerical says a 15 microfarad capacitor is connected to 220 volt 50 hertz source. Voltage is given, capacitance is given, frequency is given. Find the capacitive reactance. So you know capacitive reactance 1 upon omega c. Omega is 2 pi f, where f is frequency. Here it is denoted as nu. 2 pi at 50 hertz, and this capacitive reactance capacitance is given. So it comes out to be 212 ohm. Now if we want to find out current, then 220 volt divided by this resistance will give the current, and this will be RMS current. And suppose we want to find out peak current, in that case we have to multiply the result by root 2, right? And you know, in case of capacitance, current will lead voltage by pi by 2, and if frequency is doubled, the capacitive reactance is halved, and consequently the current is doubled. Now there is another question. It says that a light bulb and an open coil inductor, this, are connected to an AC source through a key as shown in the figure. Now the switch is closed, and after some time an iron rod is inserted into the interior of the inductor. If iron rod is inserted, then what happens? Inductance will increase, right? The glow of light bulb increases, decreases, is unchanged as the iron rod is inserted, give result. So it's obvious. As the iron rod is inserted, the magnetic flux field inside the coil magnetizes the iron, increasing the magnetic field inside it. Hence the inductance of the coil increases, right? Consequently, the inductive reactance of the coil increases, then current will reduce. As a result, larger fraction of the applied AC voltage appears across the inductor, leaving less voltage across the bulb. Therefore, the glow of the light bulb decreases. So I think you have understood. So this is all for this lecture. In next lecture, we will study AC voltage applied to a series LCR circuit and other related facts. Thank you for watching. Team Educate.